Hello, my name is Ankur, and I'm going to talk about the modulation scheme, which is Quadrature Amplitude Modulation. A few points about QAM. It's a signal in which the two carriers are shifted in phase by 90 degrees and are modulated, and the resultant output consists of both amplitude and phase variations. It can be considered as a mix of amplitude and phase modulation, like the parameters in QPSK. The only thing that's varied is phase. So in QAM, we modulate or we change the amplitude as well. That's about QAM. So let's just look at a demo of QAM in MATLAB. So this is the code for QAM. I'm choosing the size of the constellation, that's 128. So in the constellation or in the signal space, we'll be seeing 128 dots. And here, so k is 7, so log to 128 is 7. Now there's one parameter, that's eb over n naught, that's something close to the snr, so eb by n naught. So bit energy by noise, so that's 30 dBs, so it's in dB this value, and can be set to a higher value, but for now it's 30. And then let's have a look at the demo of this, before which we need to process audio. So this is my my recording where I say hi. It's a 1 second video, audio, sorry. And let's run this. Okay, function F9. So I'm converting my array into a bit stream, wherein my number of levels is 8. So this is the number of bits for PCM, for PCM. So this is the one, that's 8. It can be increased to a higher value if you want less, if you want to approximate it even more, but this is fine for now. Let's have a look. So this is the input waveform, and this is converted into a bit stream. So let's zoom in this section. So it's the 1010, so it keeps switching. So now you can see that there are 128 points, so 96 here, over here, and 16 here and 16 here. That adds up to 128. And if you look closely, there's some green. Apart from the star, there's some green region here, so which indicates the noise. So we have added AWGN. So AWGN is at this section of the code, so this part. So we are adding AWGN, so which relates to the EB over N naught that's used in the SNR formula. Okay, so that gives us the noise in the signal space, which is the uh, green area. All right, now let's demodulate it. The end. So this is the up till this is the QAM modulation, and then we are demodulating it. So this is the passband demodulation. That's the QAM demodulation. So the output matrix is data out G. So now we are going to use that value here. So this is the baseband modulation. That's PCM demodulation. Sorry. So the argument here is data out G. We should be getting where the X back that we fed into this code. So let's run it. So this is the output. All right. So let's hear it once.
Hi.
Yeah. So sounds quite similar. Now let's decrease the SNR to 10, say, and let's do the process again. So we obtain plots which are similar looking. Now let's feed this to QAM. So we see a lot more noise. There's a lot of green dots around these stars of the asterisk symbol. There's a lot of green scatter because we have decreased the bit energy by noise ratio. So it's expected to see more green areas, so a distorted signal space. Now let's demodulate it. That is the baseband demodulation. So PCM demodulation, let's do that. Hi. So there's a lot more noise, but there's this area looks very similar to the input. The dense area over here. So there's a lot more noise, and it sounds a bit distorted, quite a lot actually, because we have dropped the SNR to 10. So this is it. This is a small demo of QAM in MATLAB. Thank you.